All right, so some prior knowledge that we picked up from Algebra 1 is that if your x value repeats, like we have in this table, this is not a function. Because how can 4 go to 2 places at once? Can you go to 2 places at once? You can't be both here and at Walmart, okay? In the same way, 4 can't go with 2 and -2. So this is not a function, okay? Another way, if I were to graph this, let's just go on to an example here. Let's go ahead and look at this quadratic function. Let's go ahead and plug in some numbers. I'll plug in -2, -1, 0, 1, and 2. I'm going to go around the room and get some help. Jimena, if I plug in this -2 right here, what do I get out? Perfect. 4. Madison, if I plug in -1 into here, what do I get? Perfect. Henry, if I plug a 0 into here, what do I get? 0 times 0. 0. Thank you. Fernando, if I plug in a 1, what do I get? Aiden, if I plug in a 2, what do I get? Perfect. Now, looking at this, guys, is this a function? Yes. Every x value has its own y. All right. Now, if I want to do the inverse, what do I do to get the inverse? I flip it. So, guys, look, this is the inverse. I'm going to put the y's on this side now. I'm going to put the x's on this side now. We changed x and y. Uh-oh, that should be a 2. Okay, now looking at this new table, this is the inverse table. Is this a function? No, this is not a function. What this means, guys, is the inverse is not a function. That means this is not invertible. If something is invertible, that means you can take the inverse, and the inverse is a function. However, we tried to take the inverse, and the inverse wasn't a function. Okay, so that means this is not invertible. Guys, let's go ahead and graph these. The original function right here, -2, 4, go ahead and graph it on your own. -1, 1, 0, 0, 1, 1, 2, 4. This is the original graph. It's a quadratic. The inverse, we tried to do the inverse. 4, -2 is here. 1, -1, 0, 0, 1, 1, 4, 2. This is the inverse. So guys, the inverse right here is in black right here. That's the inverse, at least we tried to. But another thing, guys, is that it does not pass the vertical line test. It passes more than one time. It passes here and here. That's why it's not a function. You can also look at the table. 4 goes with both -2 and +2. That's not a function. It doesn't pass the vertical line test. So the answer to this question, is the inverse of the quadratic a function? No. Okay, now look what I'm going to do, guys. Look very carefully. If I get rid of this and this, let's see what happens. You don't have to do anything, just watch. Let's just look. Is this still a function? Yes. Is this a function? Yeah. Yes, because I got rid of the problematic part. Now if I graph it, it'll be fine. It'll pass the vertical line test. So I got 0, 0, 1, 1, 2, 4. Uh-oh, that's right here. And the inverse is 0, 0, 1, 1, or 2. Now, those are inverses, and they reflect across the diagonal. You see how it's a mirror image? Perfect. So, guys, what we're going to learn today is whenever you want to take the inverse of a quadratic, you can't do the whole thing. Because if you do the whole thing, this won't be a function. So we're going to get rid of half of it. Does that make sense? All right, let's move on. So go ahead and fill in those blanks. Not all functions have inverses. Those who do are called invertible. You can use the horizontal line test to determine whether a function is invertible. So the quadratic parent function looked like that. If you do the horizontal line test, it crosses 2 times. That's why we said it wasn't invertible. But if you only do half of it, now it passes the test. Okay? All right. Let's go ahead and start graphing these. So I'm going to create a table. I'm going to plug in numbers bigger than 0, because remember, we can't do the whole thing. I'm going to do numbers bigger than 0. So I'll pick 0, 1, 2, and 3. Plug it in here. Maggie, what will I get?
0.
Yep. Perfect. Bailey, what will I get if I plug in a 1 here? Minus 2. Perfect. Negative 1. Plug in a 2. Datu, what will I get? Perfect. And Trisha, plug in a 3. What will I get? Good, 7. Because 3 squared is 9, minus 2 is 7. Good, that's my table. Guys, go ahead and graph those points. And then find the inverse. Go ahead and do it. Ready, go. Graph it. Prachi, if I want the inverse, what do I do to my table? Very good. Once you guys have the tables, go ahead, graph the inverse, and I want to know the domain and range of all 4 of these problems, all 4 of these lines. Answer these 4. Y'all's graph should look like that. This is the inverse. Inverse is notated with a -1 right there. That means inverse. And this is just the original one. I'll call it F. All right. All right, I'm going to go around the classroom. Zara, what is the domain of my original one? Very good. 0 to infinity. All right, Lydia, what is the range of my original? Very good. -2, infinity. All right, now let's do the inverse, the graph that's in red. Abigail, what is the domain of my inverse? Very good. -2 to infinity. All right, Larabe, what is the range of my inverse? It's always bottom to the top. Where's my bottom at? 0. Very good. Very good. 0 to infinity. All right, guys, what do y'all notice about the domain and ranges of my original and my inverse? Yep, it's just flipped. Notice my domain here is now the range for the inverse. The range here is now the domain for the inverse. So just like you swapped the tables, the domains and range also swap. Do you guys also see how it's a reflection across that diagonal? That's what inverses look like when you graph them. Next one. Now I want numbers less than or equal to 0. So in your table, put numbers less than 0, such as -3, -2, -1, 0. Go ahead and graph it, and then answer these questions. Give me the domain and range. Sorry, one more thing. I believe you guys have a place on your page for the equation, right? Okay, so really quick, let me highlight this for you. This is the inverse right here, okay? That is the square root function. Your square root function starts at 0, 0. Where is yours? It's at -2, so it went to the left 2. So this is what it normally looks like, but you went to the left 2. So what should your equation look like? Exactly, an x plus 2. So that is your equation.
That's what I got when I plugged in y. Like I switched the x into y.
Yes, exactly. You did it algebraically. Good job. All right, next one. You guys are filling in this one. Do this on your own. I'll put the answer up here, then you can look up and check, but don't peek before. All right, let's talk about the equation. Thumbs up if you understand domain and range for both. Okay, good. All right, let's talk about the equation. I drew the parent graph up here. However, let me highlight the inverse. This is what we have now. So it looks like it reflected, right? So that means your equation, since it's facing down now, your equation should have a negative in the front, okay? It's also no longer at the origin. It looks like it moved which direction? The left. So now it's here. So first it flipped over and then it moved to the left too. So now it's here. So that means if it went to the left, what do I need? A plus sign. So that is your equation of the inverse. There we go. So you guys go ahead and try this next problem. What is the domain of the original? My original is in black. Sorry. Negative infinity to 0. Yes, that is correct. Thank you. All right. Trisha, what is the range of my original?
3.
Perfect. All right, Abigail, what is my domain of the inverse? Good. And you guys notice it's just that. That leaves this one to be negative infinity to 0. And that's correct because it starts at the bottom and then it goes up to 0. So negative infinity to 0. All right, and then I want the equation. So guys, what do I need? This inverse, it's facing down. So what should I have? Negative, and it went which direction? To the right. So I need a minus. Thank you, Aiden. All right, so that's my equation. Move on to this one. This is the last one, and then we're going to move on to a different topic.
Wait, it was negative x minus 3.
Yes. All right, guys, a hint to get you started. Do you guys need a hint for this one or no? Okay. I'll let you guys think about it. Okay, look up and check your answer, only if you're done. And then the inverse, you just switch your X and Y. And then graph it, 0, 4, 1, 5, 4, 6. And your inverse, I'm going to do the inverse in red. Okay, and it reflects across that line. So, oh, sorry, this is not on y'all's page. Sorry, this is not, and this is wrong. You can't put numbers less than 0 here because that would be negative and imaginary. I don't know why that's on my slide, but it's not on your paper. Okay, so those are those numbers. Thank you for catching that. Your domain, you should have put, Zara, what'd you put? For the original one.
Oh,
This one.
okay.
Perfect. And what's the range?
4.
Yep, you got it. Thank you, Zara. All right. I haven't asked you yet. What is the domain of the inverse? Very good. Thank you, Jocelyn. And what is the range of the inverse? Perfect. All right, guys, let's go ahead and move on to solving for inverses algebraically. Okay, so, before we move on, what's the big idea? What are some things that you learned? X's cannot repeat, good, or else it wouldn't be a function. What do you know about domain and range? They flip. So guys, the domain becomes the range for the inverse, right? And the range becomes the domain for the inverse. They switch. That was the big idea. All right, let's talk about inverses, finding them algebraically. What do you think we do first, guys? Exactly, Aiden. So first step, we're going to switch or replace X and Y. So I'm going to write f of X is the same thing as saying Y. So X will go in its spot and Y will go where the X was. Second step, solve for Y. That means we need to get Y by itself. I'm going to subtract 3 from both sides. I'm left with X minus 3 equals the square root of Y. Prachi, what do I do next? It's already square rooted.
Sorry.
There we go. Power of 2, both sides. All right. Last step, put it in inverse notation. Right? In inverse notation. What is inverse notation, guys? Exactly. I need the -1 exponent. You might see it written like this. You might see it written like this. You might see it written like this. The point is, this little -1 exponent means it's the inverse. So the inverse is X minus 3 squared. Yes, we're not done. All right, is everyone ready? Okay, remember, this is what you need to think about. This is another big idea. We started out with the square root problem. What was the transformation on here, by the way? It went up 3. Okay, so that means you're telling me it looks like this. Is that what it originally looked like? Okay, now let's look at this one. This is a quadratic. What happened here? Right, 3. Okay, so that means you're saying it looks like this, right? Do those look like mirror images? No.
It's like
Exactly. I'm gonna put the original on the same graph. Y'all said it looked like that. So guys, look what I'm gonna do. I'm going to get rid of this half. Now, do they look like mirror images? Okay, great. So what I'm gonna say is, I just want X values starting at 3 and going to the right. I just want X values bigger than 3, or you can write it like this, 3 to infinity. Now, if that confuses you, here's another way to do it. What is the range right here? Look at the original graph. What's the range? The range is bottom to top. What's the range? 3 to infinity. That means that's the domain here, 3 to infinity. This is your whole answer. Right? The range here is now the domain here. If you just leave it like this without this part, this is wrong. Because if you graph it, they don't look like reflections. So you need to add that restriction. You need to make sure you write the domain so that it looks like a reflection. Okay, so the big idea. The big idea. If you go from a square root and get a quadratic, you must define the domain. You need to tell me what the domain is. Okay, you can't just leave that part blank. You need to tell me what the domain is. Okay, here's another example where we're going from a square root and we're going to get the inverse. So first step, we're going to switch x and y. Prachi, what do I do? Very good. Square both sides. So I get x squared equals y minus 4. Jimena, what next? Exactly. I need to write this in inverse notation. The inverse is x squared plus 4. Now, guys, if you were to graph this, it looks like that. And the original one, this went right 4. The original graph looks like that. Those aren't mirror images of each other. You need to get rid of this half, right? Okay, if I get rid of that left side, then they're mirror images. So I'm going to say x can only be greater than or equal to 0. That's my full answer. Now, if you don't want to graph it, just figure out the domain or the range of this. This original graph, it looks like that. So your range is 0 to infinity. That means that's the same for here. Your domain here is 0 to infinity. And that's your full answer. So remember, the big idea is if you start with the square root and end with the quadratic, you must tell me what the domain is. Okay, try the other problems. You guys are doing this one. At the end, do I need to define the domain? No, because I'm going, I need to define the domain when I'm going square root to a quadratic. That's the only time. Here you're starting with a quadratic, so you don't have to say anything about the domain. All right, as you guys work through it, the answer will be on the board. You guys can look up and check your answer. That's your answer. I'm going to solve the next one. You guys shouldn't be looking until you have tried it on your own. Don't give up quickly. The original problem. That's the step that trips everyone else, trips everyone up. They don't know how to get rid of this 1/2. You multiply by 2. Because a half times 2 is just 1. They cancel out. So the answer Okay, now determine if the functions are inverses of each other using compositions. Compositions of functions. That means you put f inside of g, and then you put g inside of f. If you get x both times, that means they're inverses. So I'm going to write this nice and big. Everyone copy me. Write f big without the x. Next, I'm going to put g inside of it. Put g inside. G is inside of f. All right, so notice squared cancels out with the square root. I am left with x minus 8 and then a plus 8. Those cancel out. I'm just left with x. And that was my goal. If I'm not left with x, those are not inverses. Now, you can't just stop there. You have to test it both ways. Next, everyone copy me. I'm going to draw the second equation nice and big. I wrote this one without the x. Everyone do that. Now, I'm going to put f inside. The first time I put g inside. Now I'm going to put f inside of g. Now simplify it. 8 minus 8, that's just 0. And then the square root cancels out with the squared. I'm left with x. If you're left with x both times, that means f and g are inverses. All right, I'm going to do the answer real quick. I'm going to write one of the problems really big. I wrote this one really big. I'm going to put this inside. I'm going to put this inside. Okay, now I simplify. 3 minus 3, that's 0. I'm left with square root of x with the squared. Those cancel. I'm left with x. So I'm good so far. Make sure you test it the other way. Now I'm going to write this one big. And I'm going to put f inside. Put f inside of here. Okay, show me step by step. Square root cancels out with the squared. I am now left with x minus 3 plus 3. Negative 3 plus 3 cancels out. I'm left with x. I was left with x both times. That means f and g are inverses. If you got anything else other than a single x, then they're not inverses. And that's the end of the lesson.